Assalamualaikum and good day. I am Marissa and we are from Group 2. This is our visual presentation for this project. The contents of this presentation includes the paper reviews, simulation results, motion control system details, and the conclusion. For my paper review, I choose a first-order model to assess computer architecture sustainability that was published in 2022 written by Living Checkout. The paper discussed about a practical approach to evaluating environmental impact of computer systems in the early design phase. The proposed models balances between simplicity and usability by using proxies like chips area and energy consumptions to estimate embodied and operational emissions. It effectively addresses real-world scenarios such as data centers and mobile devices. While the model is intelligent, I think it could benefit more from further validation with real product data and more comprehensive case studies. Despite the struggle shown, it still provides a valuable framework for promoting sustainability in computer architecture.
Good evening, I'm Afizuddin and I will be sharing a brief review of the paper titled A Study on Instruction Formats on Computer Organization and Architecture, written by Renas Kejab Asad in 2021. The paper begins with clearly defining instruction formats as the structural blueprint of machine instructions. It highlights how each instruction is composed of various parts, primarily the opcode and the operands, and how these parts are arranged within the instruction. This foundational understanding is critical because it determines how processors interpret and execute commands. What stands out is the author's detailed explanation of the assembler's role in this process. The paper walks us through how high-level instructions are translated into machine-level code. It includes aspects such as handling labels, defining operand lengths, and applying addressing modes. This step-by-step description makes the complex process of instruction translation much more approachable. The analysis of the individual components, specifically the opcode field, operand field, and addressing mode field, is also very well done. The paper clarifies how these fields work together during the instruction execution cycle, giving readers a clearer picture of how a computer's controlling and data path function in real time. Overall, the paper is logically organized and easy to follow. It successfully bridges theoretical explanation with practical application, making it a valuable educational resource, whether you are a student learning the basics of computer or a practitioner revisiting instruction set design. This paper offers solid insights. To conclude, Renas Kejab Asad works not only outlines the technical aspect of instruction formats, but also demonstrates their real-world significance in CPU design and operation. It's informative, well-structured, and highly relevant for anyone studying or working in computer system. Thank you.
Let's move on to the third paper review. So this paper discusses about the impact of hardware features on the processor instruction set architecture, or better known as ISA. This paper is primarily concerned with low-level language and machine-level execution, specifically about how hardware features affects ISA. Machine code and assembly language are tied directly to a specific ISA, unlike high-level languages that depend on compilers instead of CPU directly. So, machine code written on one ISA cannot be directly run on another ISA, so it makes lower-level code non-portable. To translate or emulate machine code from one ISA to another is difficult due to differences in registers, flags, memory handling, among other things. So this paper proposes to create a universal abstract ISA to help bridge these low-level compatibility gaps. So this innovation has potential for better cross-platform compatibility and software portability. However, of course, when you implement something new, it would be technically challenging, especially in handling interrupts, input-output, and virtual memory across diverse processor architectures.
The last paper review is investigating the impact of formal methods on enhancing performance in computer architectures. Explore how mathematical techniques called formal methods can improve computer system. Formal methods help check if hardware and software are working correctly, reduce errors, and make system more reliable and secure. This paper shows how they can boost performance in areas like speed, power, efficiency, and reliability, especially with complex systems like heterogeneous processors. Next, it also discusses useful tools like model checking and automated theorem proving, but notes that this paper review needs more detailed models and clearer explanation are needed. In short, formal methods are powerful tools to design better, faster, and safer computer systems.
So, what is SMP cache? SMP cache is a simulator that uses memory access to help analyze and teach how cache memory works in systems with multiple processors. It uses predictions and parallel processing to guess what data will be needed next and loads it early, which helps in reduce waiting time and improve performance. The use of SMP cache in this project was used as a simulation tool to explore the behavior of cache memory systems, particularly in uniprocessors configurations.
So now we are going to analyze how the global miss rate changes with varying cache and block sizes for different trace files. So we are going to start off with hydro. So this is block 1 for hydro, block 2, block 4, block 8, block 16, block 32, block 64, block 128, block 256, block 512. So now we are going to analyze through table and graph. So as we can see, the global miss rate dropped significantly, especially after 1 kilobyte, and we can observe less returns beyond 4 kilobytes. Next is NASA 7. So this is block 1 for NASA 7, block 2, block 4, block 8, block 16, block 32, block 64, block 128, block 256, and block 512. As we can see, the global miss rate for NASA 7 started with a high miss rate, and the curve flattens faster than hydro. Next is CEXP. So as you can see, the miss rate drops significantly after 0.25 kilobytes, showing extremely cache-friendly behavior. So this indicates that CEXP benefits greatly from even small cache sizes. For MDL-JD, it has strong spatial locality and the steady decrease in the miss rate, becoming efficient around 8 kilobytes. Moving on to EAR, so global miss rate drops quickly and stabilizes at around 6%. And as for COMP, the miss rate reduced steadily, but it has little to no change above 2 kilobytes. As for WAVE and SWM, they both show consistent cache benefits, though SWM slightly outperforms WAVE in miss rate at larger caches. And last but not least, UCOMP, it behaves almost similarly to SWM. So comparing all the trace files, we can see that CEXP has the best cache behavior with minimal cache size. Hydro, MDL-JD, EAR improve significantly with medium cache, and NASA 7 and UCOMP benefit less due to irregular access patterns.
Next, what is GitHub? Git and GitHub are two separate identities, as Git acts as a tool while GitHub acts as the hosting service. Git is a tool used to track changes in source code. It works locally on your computer and was created by Linus Torvalds in 2005. It is used through the command line and helps manage versions of your computer both locally and remotely. On the other hand, GitHub is a cloud-based platform that hosts Git repositories online. It was launched in 2008, now owned by Microsoft, and offers a web-based interface with collaboration features like pull requests and issues tracking. In short, Git is the engine and GitHub is the garage that hosts and manages your project online.
So now I'm going to talk about GitHub. First, to create a repo, you need to click on this specific button, enter your name into the repo name, and just create the repository. If you want to add any messages, just insert it in the description box. So now, to clone one repository from the internet, click here, and from the github.com, it shows the repo that you have collaborated in. So here's mine, but due to I have the repo in my local drive, I just need to edit here. So now moving to the next part, adding the collaborator. We need to add collaborator from the GitHub website here. Then click settings, click collaborators, and insert your collaborator name. After inserting their name, just add them, and they will receive a notification of invitation to the repository. So now moving to the creating file for the GitHub repo, just click in the Show in Explorer button. Then add a new file, such as here. I will name it implementation. So upon creation of the file, just close it, and GitHub will automatically ask you to commit the changes made to the main repo. Click here, and to allow others to see what changes have been done to the repository, just push it to the origin. Wait for a moment. So as you can see here, the changes made have been pushed to the origin, and you can see the difference made in history.
To To conclude our project on computer architectures and organization, we gain a lot of knowledge beyond our syllabus. In part A, we studied a complex research paper which helped us understand advanced topic in architecture. In part B, we explored SMP cache software to analyze cache performance in multiprocessor system. Part C introduced us a GitHub where we learned how to collaborate and manage source code with others. We did face challenges, especially running the tools and understanding the technical terms in the paper. Time management was also tough due to other assignment. But overall, we learned a lot, helped each other, and gained hands-on experience with tools we hadn't used before. This project truly expanded our understanding of computer architecture. Thank you.